Okay, hopefully you see it full screen now. Yeah, so Climameter, just to jump into the discussion very heavily, is, let's say, closer to the storyline approach that we are discussing, but I would say it's also another approach based on the idea that the events recur in the weather, or sometimes they happen for the first time. So saying that, I will present this on behalf of the Climameter team, and I'm a researcher at the National Center for Scientific Research in France. And as you see here, Climameter will basically be a tool to somehow attribute events that are more related to the atmospheric dynamics, what we call the atmospheric circulation. And here you see a picture of Hurricane Irma that I will use as an example to guide you through the features of Climameter. And I think it will be interesting to have this event because it really affects heavily populations coming from different wealth and from different countries in the Caribbean. Okay, so yes, when I start to get interested in attribution, it was more or less the end of the previous decade, and the confidence, in fact, for attribution studies were limited to the link that we have between the rise in the global temperature and the extreme events. So before we were able to attribute mostly just extreme heat and extreme cold events to climate change because of the link with the CO2 emissions. And so my research focused more on what was here, that is events, as I said, related to the weather. So tropical cyclones, severe convective storms, and also extratropical cyclones. And this has already been said, what is the attribution. So I will skip this. And this has also been said when we want to study a single extreme event, then we have to define the event. So you've seen that this is problematic and there is not a unique way of defining the event. And then we have to build a world with and without climate change and compare the probability of the event happening in the two worlds, and also rule out some mode of variability such as El Nino, or the fact that the Atlantic or the Pacific Oceans are warmer or cooler in different decades can trigger your event. So this is also to be separated in the attribution of a single extreme event to climate change. So when we start Climameter, we take basically the need for having a rapid attribution tool that could take into account the meteorological patterns leading to an extreme event. So I give you a simple example, like extreme precipitation in Naples, could happen for 2 or maybe 3 reasons. We can have Mediterranean cyclones, we can have an extratropical cyclones, but we can also have thunderstorm. So if we take just the statistical approach and we look at rain occurrence, for example, daily rain in Naples, and we want to know if the Mediterranean cyclones are becoming more frequent, then just taking rain over one day is not a good event definition, because the rain in Naples can be caused by thunderstorms that can be totally unrelated to Mediterranean cyclones, okay? So here the idea is, if the questions we want to answer is an hurricane becoming more intense or more probable with climate change, not rain, then we have to go to the level of the meteorological object, so the level of the hurricane. So we have to condition attribution to the meteorological object that is causing the impacts. And this is the goal of Climameter. So Climameter is this rapid experimental framework that we have developed in France at APSL CNRS within the XAIDA collaboration, and is a very young tool because we start in July and we are operational since July. And we have already a consortium of scientists coming from several institutions, American institution, European institution, African, and also colleagues from Singapore, and that's why I was there last few weeks. And as you can see from the events that we've covered, we covered, for the reason I've explained, mostly rain, but we have also heat waves, cold spells, and windstorm. And in our website, that is, you will reach it from the QR code in the last slide. You can see that we have covered already about 40 events in 6 months. And most of them have been influenced by climate change in some way. Was very surprising for, we didn't know that we would find this when we start. And Climameter also featured a diagnostic about the rarity of the events. And you can tell, for example, if the event is unique or not, if it's the first time that it happens in our dataset. And this is an important feature because it can give us the confidence in the kind of statement that we can make about the event. So as I said, the idea of Climameter, if we take this scheme that is the one for Irma, let's start from the right-hand side. So we have the impacts of the event. So the world weather attributions, as Freddy said, start from this level to define the event, and then take one of the hazard or few of the hazard that have caused the impacts and study the changes in probability. Climameter goes a step even before, and so it looks at the weather phenomenon causing this cascade of hazard and impacts, and therefore try to identify the changes on this object as caused by the greenhouse gases emissions or the climate variability. So I give you the example of Hurricane Irma, but I go very quickly. So the idea is that Irma was, you see here the trajectory in the 2017, and where it's red is basically the time that Irma spent as Category 5 hurricane. So it was record-breaking and that very widespread impacts over all the islands in the Caribbean and even the United States. Here is some list of the impacts of Hurricane Irma that usually I show to give an idea that the impacts were both from rain, winds, and they were on energy, infrastructure, and also produce casualties and destruction of like transportation and also tourism. So the impacts were different depending on the islands, but there were impacts almost everywhere. And about the methodology of Climameter, the way it works, so we want to be very rapid. So normally we publish the report 1 or 2 days after the event is over. This is really, the goal is to communicate with the press about the events and to have some data immediately after the study. So we use reanalysis. We don't use climate models for the moment. Then we look for events that look similar to the event to attribute. So we take, for example, all the hurricane occurring from 1979 to present in a defined area. And then we look how the hurricanes change for that area in the recent period, that is 2001 present, and the first part of the period that we have in the data, that is 1979. So we take difference between hurricane affecting an area in the present minus that in the past, and we look at temperature, precipitation, and winds, and we diagnose the hurricane by the surface pressure, in this case average over 2 days. And of course then we have to assess the influence of the natural variability, and we will come up with some statement for the press. So very quickly again, the way it works, so you will find all the figures in the, there is a single figures for Climameter in the report. It's always the same, and it features on the first line the event. So here is the surface pressure anomalies during Hurricane Irma for the 2 days of the analysis over Santo Domingo and Haiti, and you can see that we have this low pressure area that corresponds to some temperature field. Of course, we see the precipitation caused by the hurricane and the high wind. And then the analysis gives you the difference present minus past, present hurricanes minus past hurricanes. And you see here that with respect to the other methods that have been presented before, we have changes that are geographical changes. So we have temperature changes, but also precipitation changes and wind speed changes. So we have the compound aspect of the hurricanes. And you can see that, for example, for the Irma, we have increase of precipitation for hurricanes in the present minus hurricane in the past in San Juan and Santo Domingo, but dry conditions in this area. And we also have increase in winds, but they are not uniformly distributed over the domain. So this also answers one of the questions. And then we can go to the level of the city. This is important for the legal aspect because you can see here that the impacts are different if you are in Port-au-Prince or San Juan and Santo Domingo. Blue is precipitation and green is wind. So you can see that, for example, we have increase in precipitation in San Juan and Santo Domingo, but decrease in Port-au-Prince. This again goes to some of the discussion that we had about the definition. Then we have a way to take into account the of this, but basically it's based on how are the hurricanes in the present compared to the hurricanes in the past occurring with a different phase of the El Niño, the Atlantic multi-decadal oscillation or Pacific decadal oscillation, yes, no. And using this, we can build the summary. This is what you find in the press. So we have 2 meters. One is how the event is influenced by anthropogenic climate change compared to natural variability. And one is how the event is look similar to the one that we have in the database. And then the summary that we give to the press is composed by 3 elements. One is the changes in intensity. So hurricanes landfalling in the Caribbean, similar to Irma, are 0 to 40 millimeters wetter in the present than they've been in the past. Then we have a statement on the how common is the event. And then we have the statement that is interesting for you, that it depends on this meter. And for this case, we mostly ascribe the heavy precipitation of Hurricane Irma to human-driven climate change, and natural climatability played a modest role. So you see that the meter is never on the red or on the green completely. It's somewhere in between. It will depend on the event. And this, I think it's the element that is interesting for you. If this is on the red, the confidence that we have in the study is low. And therefore, the statement that we have here is weaker. This is similar to the diagnostic that the colleagues of the World Weather Attribution do. Just the last slide, the perspective of Climameters, of course, is to get out of the rest of the world. We want to see more events that cover the south of the world. And these will need further collaboration. We want also to include model projection to strengthen the findings. And this is something that is more interested for you. We have already some peer-reviewed research that take into account hazards and risk, and we also go to the damage level. I can talk more in the question times if you want about this. And of course, we want to cover more impacts on health, energies, and transportation. And we also have some peer-reviewed research that goes into this direction. Sorry for being a bit too long. This is the peer-reviewed research. We have a paper out, preprint out. We got 2 minor revisions, so it should be out soon about the Climameter. So it will be, the methodology will be validated, and the basic methodology for this is presented in this paper of 2022. The QR code directly drive you to the website where you can see the summary and the results for the other events. And if you write to this email, you will get to my email. So if you have further questions after this workshop, you're welcome to write. And please follow us on X. Thanks.